Today, Dr. Zoon will teach you about clay car prototypes. After reviewing some real-world applications for clay prototypes, Dr. Zoon will show you how to make an armature. Finally, you'll learn to shape and form clay into a scaled prototype of a car.
Hello kids! Today we're going to be making a prototype of a car from clay. One of the processes in the design of any car is to make a model of that car. Nearly all car designs start by making sketches of a car like this. Once the designer is satisfied with the look, a scale model of that car is built using clay. Design details are studied, and even aerodynamic testing is done on the models to determine what modifications need to be made. As the process goes on, larger models are built and designs are modified until finally a full-size model of the design is constructed again from clay. This full-size model becomes a template for making the tools and dies that will ultimately make the parts for the real car. These models are also called prototypes. Webster defines a prototype as an original model on which something is patterned. Our prototype is going to be a scale model car, a car that proportionally looks just like the real thing, but is smaller. In fact, we're going to make the clay car prototype at a 1/20th scale. A 1/20th scale indicates that a car that was 20 feet long would be scaled down so that the model was only 1 foot long. This scale, 1 to 20, is a proportion. All the measurements on the prototype will be at this same proportion, 1 to 20. Let's look at an example. If the width of a full-size car were 5 feet, what would the width of the car be for a 1/20th scale? Well, 5 feet is the same as 60 inches because each foot is 12 inches and 5 times 12 is 60. To find out the size of the model, we would take the 60 inches and divide by 20 because the proportion is 1 to 20. When we divide 60 by 20, we will get 3 inches, which would be the width of the model car. For any measurement on the full-size car, we can determine a corresponding measurement for the scale model car by dividing the measurement by 20. If we want to make a 1/5 scale model, we would divide the measurements by 5. Of course, to make a scale model car, we must first have a full-size car to copy, or we have to come up with our own unique design. In the clay car activity, your teacher will let you know if you are to design your own car or make a model of a real car. To demonstrate the process of making a clay car prototype, I'm going to make a scale model of a car I had when I was in high school, a 1966 Ford Mustang. I found a nice picture on the internet that showed a side profile of a 66 Mustang. I made a printout of that picture, but now I need to magnify the picture to get the right scale. The overall length of the 66 Mustang was about 183 inches. Converting that to 1/20th scale, the length of the model would be 9 1/8 inches. We will need to use a copier with a magnification mode or a computer graphics program to increase the size of the picture so that the length of the car is 9 1/8 inches. Here's our scaled side view. As you can see, our picture is scaled now to 1/20th so that the length of the car is 9 1/8 inches. We will do a similar procedure with a picture of the back of the car so that we can have a scale picture of it as well. The overall width of the 66 Mustang was about 68 inches. Dividing this width by 20 gives us a scale width of 3 7/16 inches. Using the copier again, we magnified our picture to give us a picture width for the car of 3 7/16 inches. We will be making our model on a base plate, a piece of 3/4 inch wood. I have cut this piece of wood so that we have at least 3 inches of border around the area where the scaled model will be located. I have also drilled 2 holes and countersunk them on the bottom side. I have also drawn lines through the center of the length and the width of the base plate. On this base plate, we are going to build an armature. You may have heard of an armature before, but it may have been in reference to the armature of a motor. This is a different kind of armature. In clay modeling, an armature is defined as a framework serving as a supporting core for clay sculpture. For our armature, or support framework for our clay car, we're going to use wood and blue foam. The base of the armature will be a rectangular piece of 1/4 inch thick wood. This piece should be about 3/4 inches narrower than the width of the car, which would be about 2 3/4 inches wide. The length of the base should be about 1 inch longer than the wheelbase of the car. The wheelbase of a car is the distance between the centers of the two wheels on one side of the car. The wheelbase for our scale model is going to be 5 3/8 inches, so the length of our wood base will be 6 3/8 inches. Let's measure and mark the width and length of the base on a piece of 1/4 inch wood. We will also want to cut out notches for where the wheels will be on our model. Each notch should be 3/8 inch wide and 1 1/2 inches long. Kids, we're going to use a bandsaw to cut out the base of the armature. Please ask your teacher what tools they prefer you to use in cutting these pieces of wood, and use proper safety procedures for each tool you use. That includes, of course, wearing safety glasses or goggles to protect your eyes. Once we have this piece of wood cut, we will use it as a template to cut a piece of foam the same shape to use as a spacer between the armature base and the base plate. The thickness of this foam piece should be equal to the clearance between the bottom of the car and the ground. Let's measure that distance on our picture. That distance is about 1/2 inch, so the thickness of our foam spacer should be 1/2 inch. I have 1 inch thick foam available, so we will use the armature base to mark the outline of this piece to be cut, and then we will cut it to the correct thickness. Once that outline is marked, we can cut out the rectangular shape of the foam. This foam can be cut with a styrofoam saw, but the best way to cut foam to shape is by using a hot wire cutter like this one. This cutter uses electric current passing through a piece of thin nichrome wire, causing the wire to heat up. The temperature of the wire becomes hotter than the melting point of the foam, enabling the wire to easily cut through the foam. Kids, whenever you use a hot wire cutter, be sure to keep your fingers away from the wire. It is hot. Let's cut out the spacer rectangle from this piece of foam. Once we have the rectangular piece cut, then we need to cut it to thickness. With the wire cutter turned off, place a square 1/2 inch from the wire. Holding the square in position, turn the hot wire cutter on and carefully slide the piece of foam on edge through the cutter, keeping one face of the foam against the square. Once we have the armature base and spacer cut, we need to attach them to the base plate. We center the wood on the center lines and mark around the outline of the wood. Holding the armature base to the base plate, we will mark the positions of the base plate hole using a T-pin. Simply insert the T-pin into each hole and press firmly to mark the position on the armature base. Let's use a 3/32 inch drill bit to drill pilot holes in the wood at those marks. We will place the spacer on the base plate and place the armature base on top of the spacer. Using panhead screws that are just long enough to go through the base plate, spacer, and armature base, we will fasten the armature base to the base plate. Once we have the wood armature secured to the base, we will use a piece of blue foam to form the rough shape of the car. To do this, we will make a block of foam that is at least the same length, width, and height of the model. From the scaled pictures of the side and back views of the Mustang, we will cut out the outlines of the car to use as templates for shaping the foam block. We will attach the side view to the side of the block, aligning the front of the template on the front edge of the foam, and the bottom of the template on the bottom edge of the foam. We will then draw around the side view, transferring the side profile of the car to the block of foam. We will also attach the back view of the car to the back of the block and mark the outline of the back view. Remove the templates and use the hot wire cutter to cut the general shape of the car from the block. However, we want to keep the cuts about 3/8 of an inch inside the profile so that we can add a layer of clay to the foam to make the finished surface. The exception to this will be at the bottom of the car. The bottom surface will be 1/4 inch in from the template line and will be cut straight through the tire positions. With the side view cut out, we now need to cut out the back view of the car. To do this, we'll reassemble the pieces we cut off for the side view and loosely tape them back together. Using the shape of the rear view of the car as a guide, we will cut out the profile of the car as seen from the rear, again staying 3/8 inch in from the marks to allow for the clay overlay. Now that we have the general shape of the car cut out, we'll reattach the side view template to mark the position of the wheel wells. We will also mark the position of the wheel wells, the area where the tires go, by using a T-pin, punching through the template into the foam about every 1/8 inch. We'll remove the template and repeat the process on the other side of the car. We have the outside shape of our foam block complete. Now we need to remove foam to make the wheel wells. For this task, we will use a sharp hobby knife. We will make a cut about 1/4 inch outside of the series of holes we made using the T-pins. We will follow the curve of the wheel well around these points, cutting the foam to a depth of 3/8 to 1/2 inch. Once we have the curve cut, we will cut the wheel wells to depth, using our hobby knife to cut into the bottom of the foam about 3/8 of an inch in from the side of the car. Continue to cut away foam until the entire wheel well is clear. We will repeat the process for the other 3 wheel wells. Our foam block is cut to size, so let's attach it to the wood armature base to complete the armature structure for our model. Spread white glue over the armature base and place the foam block in position on the base. Allow the glue to dry for 30 minutes. As the glue is drying, we will coat the foam with shellac, which will help the clay adhere to the foam. While we are waiting for the glue and shellac to dry, let's take a look at the tools and materials we will be using to add the clay skin to the armature. First of all, we have clay. Of course, this is no ordinary clay like you might find in your backyard. This is hard styling clay. This clay is hard at room temperature, but softens when heated, making it easily molded. The best temperature for softening the clay is 135 degrees Fahrenheit, or about 57 degrees Celsius. We will use this small oven to soften our clay. Let's go ahead and turn the oven on and let it warm up to about 135 degrees. We will insert a metal digital thermometer into the oven to make sure the temperature does not get above 140 degrees, as the clay will begin to liquefy at that temperature. Once the oven has reached the proper temperature, we will place a couple bricks of clay into an aluminum pan and put them in the oven for about 30 minutes to bring them up to temperature. Check the temperature occasionally to be sure the clay is at the proper temperature. The process of working with clay is fairly simple. We will apply an outer skin of warm clay 1/2 inch thick over the armature. Once we have this clay skin applied, we will begin working with a variety of modeling tools to shape the clay. For general shaping and clay removal, we will use a clay steel like this one. This clay steel has the name because it's made from spring steel and is used to shape clay. When using the clay steel, we will hold the steel at a 45-degree angle to the clay surface and drag the steel across the face of the clay. We need to be sure we have our fingers close to the edge of the steel that is in contact with the clay. If several passes are needed to remove enough clay, each pass should be at a 45-degree angle to the previous pass. This will keep the surface smooth. For smoothing the surface of the clay, we will use slicks. Slicks can be made of wood or plastic and are available in a variety of shapes depending upon the size and shape of the model. They are used like the steels, holding them at 45 degrees with our fingers close to the edge of the slick, dragging the slick across the surface we want to smooth. For detail work, like adding contour lines to our model, we can use wire loops like these. Depending upon the size and shape of the cut we want to make, we can choose the wire loop that is closest to that shape. To use a wire loop, we hold the tool handle near the loop and press down with the tool at a 45-degree angle. Then we can drag the wire loop tool to form the cut in the clay that we desired. To remove more clay, we simply make more passes with the wire tool. Another tool we will use will be a sponge. The sponge can be moistened with water and lightly rubbed across the surface of the clay to further smooth the clay. There is another tool that we will need to make ourselves. That will be a template. A template will provide us an accurate shape to guide us in conforming the clay. This template can be made from light cardboard or cardstock. We will make a template for the side view of the car using a copy of the side view picture. We will cut out that picture of the car. We will cut the car in half and place the front half of the car on one piece of cardstock and the back half on another. This will allow us to have enough cardstock to hold its shape while in use. All right, all the tools are here, the clay is warm, and Dr. Zoon is ready to get his hands dirty. Let's add some clay to our car. To begin adding clay, we will remove the clay from the oven, break off a chunk, and place the rest of the clay back in the oven to keep it warm. Break off small pieces of clay from the chunk and spread it evenly over the armature, trying to maintain a depth of 1/8 inch all over the model. We will work our way around the model, adding clay and pressing it to the armature until we have the entire surface covered with a 1/8 inch layer of clay. We will repeat the process with warm clay, adding layers of clay until we have about 3/8 of an inch of clay over the entire surface of the car. Once we have the car covered, we will begin shaping the clay using a clay steel. Let's begin with the front hood. We will hold the front template against the side of the car and take notice of where excess clay is on the car. Using the clay steel, we begin scraping clay from the surface of the hood, moving the steel across the clay in opposite directions with each pass. We will collect clay that we scrape off, roll it back into a ball, and place it back into the oven to be used again. Let's check and see our progress in getting the hood of this car shaped to the template. We will keep working on the hood, removing clay until the template and car match up. If there are nicks or grooves in the hood surface, we will need to add some fresh warm clay to the area and scrape it back down. Let's get the front windshield scraped to form as well. This is looking pretty good. Let's work on the top of the car. Again, we will use a template to see where to remove clay and scrape the clay using the clay steel. The trunk of the car is next. Let's scrape it and the back window down to fit the template. Okay. It looks like the top surfaces are in pretty good condition. Now let's work on these sides. For the sides, we will look at back views of the car. Since these views are distorted by perspective, we have to try to approximate the shape of the sides. We will work from front to back on the sides of the car, removing clay and shaping the sides as we refer to the pictures. Once we have the tops and sides in the right shape, we can use the slicks to further smooth the finish of the clay. We will use the same motion with the slicks as we did with the clay steels. Hey, this is looking more like a car all the time. Let's work on getting some details into this Mustang. Some details will be a matter of looking at pictures of the Mustang and approximating things such as curves in a windshield or the sharp lines of a bumper. We will use the clay steel to form these details as accurately as possible. If we make a mistake, it's okay. We can simply put warm clay back on the model and try again. We also need to smooth the inside of the wheel wells. Again, we can mark the position of the wells with the template and T-pins and then scrape and smooth the clay inside these wells. Once we have the wells underway, we can check the wells against the wheels that we will add to the Mustang later. Looks like they will fit. Let's go ahead and add as much detail to the Mustang as we can by using pictures and the tools we have. Watch as the model begins to take shape with each detail that we add. Wow, this is really exciting. A '66 Mustang just like the one I used to drive. We added some detail to our model, and there are more details I would like to add. The nice thing about working with this hard styling clay is that you can come back to it a day, week, month, or even a year later, and the clay will still be able to be worked. We could leave our model like this, but let's put some wheels on it before we call it done. To add wheels, we will remove the car and the armature from the base by removing the 2 screws from the bottom of the base. I have cut 2 pieces of brass tubing to fit between the inside of the wheel wells on each side of the car. I also cut axles about 1/2 inch longer than the brass tubing. Let's assemble our wheels, axles, and tubing and attach the assembly to the bottom of the armature using a cool melt glue gun. Here we have it, our completed clay model of a 1966 Mustang. Kids, it's been a real blast to work with you on this project. I hope that you have fun making your clay car too. Until next time, this is Dr. Zoon saying, see you real soon.